Okay, hello everyone. Today our topic is about thermistor. Okay, so let's move into the first question. So for thermistors, like this symbol, like here we can find is combined with one rectangle and two lines like this way. Okay, so for thermistor, you can find this name that is thermal and resistor, right? So for thermistor, we can find that maybe it has some relationship between thermal energy or like the temperature. Okay, so maybe for thermistor, we have when temperature increases and the resistor or resistance of the thermistor will decrease like this way. Okay, when temperature will decrease and the resistance will increase. Okay, this is for thermistor. How do you use? Okay, so let's move into this question together. Like here, in this figure, a 12 voltage battery supplies a current I to a circuit, and the circuit contains a thermistor and a 1000 ohm resistor in parallel, and with a 500 ohm resistor in series, like this way. Okay, so maybe here let's move into there's a sub three question. Like here, so first question is the combined resistance of the thermistor and a 1000 ohm resistor, right? And we can find it's a question as for this thermistor and this 1000 ohm resistor, they combine together, right? So maybe here you can find they are connected in parallel, right? So maybe you can just using the parallel formula, like the total resistance equals to the R1 or like 1 over R1 plus 1 over R2, right? So maybe you can say, oh, here's 1 over total resistance, and here is 1 over R1. Maybe here is for the thermistor resistance, right? It is 1000. And for R2, it is 1000 ohm resistor that is plus 1 over 1000, right? So this is for these two part. Okay, so we can find that total resistance here is 5 ohm resistance, right? So this is for A1, not very difficult. And for A2, that's the current I. What is the value of this? So maybe here we can find, to find the I, you have to using the ohms law, right? Using the I equals to the potential difference U over the total resistance R, right? So maybe here we can find on the left it is 500 ohm for the resistance, and on the right it is 5 ohm resistors either. Okay, so maybe here you can say, oh, here the total resistance here is 500 ohm plus 500 ohm, that is 1000 ohm resistance, right? So here is 1000, and we can say, oh, the fractional number it is U. Here is 12 voltage, and for here the downward here is 1000 ohm, right? So maybe you can write down the formula, and the final answer is like maybe for 0.012 amp, right? This is for the second question, also not very difficult. Just you're very familiar with Ohm's law and you can write down the formula very easily, right? This is for second question. And for the third question is the potential difference across 500 ohm resistor, right? And you can find on the left, it can consider as one 500 ohm resistor, and on the right is also for 500 ohm resistor. So they have the same resistance, so they can just consider they equal to each other, and they can just cancel with each other. And because of they have the same resistance, that means they divided the potential difference together. So maybe total potential difference is 12 voltage. So on the left is 6 voltage, and on the right is also for 6 voltage, right? This is for 6 voltage and 6 for 6 voltage. Okay, so I guess here potential difference across 500 ohm resistor is 6 voltage. Okay. So final answer, we have to set down that is 6 voltage. Okay. Okay, and on this question, it has a question that the temperature of the thermistor is increased, that the resistance decreases, and say the effect of its change in resistance on the current through the 500 ohm resistor. Okay, so maybe for this question, I think it's a little bit difficult for you to understand, but don't worry. You can just try to analyze each part and to analyze its effect. Like here, first, if the temperature increases, right, and that means the resistance of the thermistor is decreases, right? So if you combine together, and you can write down the formula for R total, 1 over R total equals to 1 over the R resistance for the thermistor, and plus 1 over the 1000, right? So if this value decreases, that means the total fraction number will increase its value, right? And for total formula on the right will increase the value, right? So you can find 1 over R total equals to an increasing number. So that means the R total must be decreasing, right? So 1 over a decreasing number that must be increasing, right? So we can say, oh, if the resistance of the thermistor is decreasing, that means the total resistance here is also decreasing. Okay. So on the left, it is decreasing the resistance, and you can say, oh, maybe for on the left the resistance and on the right 5 ohm resistor, and that means 5 ohm resistor can have more potential difference side, right? Because we said before, like with if the resistors combined in series, that means it will divide the potential difference, right? So on the right, it will divide more potential difference on 5 ohm resistor, right? So we can say, oh, maybe here for 12 voltage, maybe on the past it will 6 voltage and 6 voltage, and right now maybe it's 6 voltage and 8 voltage, right? Like this one. Okay. So maybe if we have more potential difference, that means the current will increase, right? Because using ohms law, we know that current equals to the potential difference over resistance. If the resistance doesn't change, but the U increases, that means the current must increases, okay? So for this question, we're choosing like it will increase the current on the resistance, okay? So I guess it's not very difficult, right? So let's move into the next part is about power and energy, okay? So we have said before, like the power on the resistance, you can use in the formula that P equals to like the U times I, okay? And for this formula, we can also put ohms law into it. Like you can just making U as I times R times I, that is I squared times R, right? And you can also like let the I equals to U over R, like here is U times U over R, that the total answer is U squared over R, right? This is for the power. And for the like the energy or like the work done, we can use the formula like work done or energy equals to power times time taken, right? So maybe here you can also write down like it equals to UIT, like this part times time taken, right? And also like I squared R, you can also write down I squared RT, right? You can also write down for this formula U squared over R, that is U squared over R times time taken, okay? So this is for the work done right here, okay? So maybe here you have a question like figure shows two resistors X and Y are in series, okay? And here you can find the current is I, that means I passes through X and Y together, right? So we can say, oh, for X potential difference is I times R, right? Because using Ohm's law, the potential difference equals to I times R, okay? So power here you can use in the formula that power equals to U times R, right? U times I, right? So I is I, and for potential difference is IR, so it's I times IR, that means I squared times R, right? Like, so maybe for next question, you can find they're combined in series. So current equals to each other. So here current also equals to I. And we knew that for here is 2IR, right? Because the resistance is 2R. So 2R times I equals to 2IR, right? Using Ohm's law. And power, you can use the formula P equals to UI, right? That is 2IR times I. It is 2I squared times R. Okay, this is for total power right here. Okay. And here's another example like here. Please try to do this problem, okay? I give you several seconds, okay? Please try to do so, please. Okay. Okay, so let's move into this question together, right? So for the first question, it is that the power output of the power station. So for this question, I think like the output for power station, just using the formula, right? Power equals to the potential difference U times the current I. So here for U, it is a 11,000 voltage, right? And we have to times the current, it is 750 ampere, right? So this is for the first question. Please remind the unit here for power is what? Okay, this is for question one. And for question two, it's that the potential difference across 1.5 ohm of the power lines, right? So if the power lines has 1.5 ohm resistance, we can use in the ohms law, right? Because like for resistors or like for wire, they're both a kind of components in the circuit. Okay, so we can use the formula that U equals to I times R. Okay, potential difference equals to current times resistance. So here for current is 750 ampere. And for the resistance here, maybe we can find is 1.5 ohm, right? This is for this formula. Okay. So finally, you can write down the formula right here. Maybe I guess it is maybe it's for 75 and 37.5 is about sorry, sometimes I cannot calculate it very clearly. Like 75 is like the final answer, it is I guess it's 11. Oh, okay, it's 11,120. Okay, this is for ohm. Sorry, for voltage. Okay, this is for the second question. Oh, sorry. Here is the final unit is 5. Okay, 1,125 voltage. Okay, this is for second question. And for third question is find the power supply to the factory, right? So for factory, we want to calculate the power. So we must use the formula that power equals to the U times I, right? So here I it is 750 ampere. It is no doubt, right? So now you have to find the voltage right here. So we have the voltage on the power station. It is 11,000 voltage, right? So maybe you have to subtract the voltage on the wire, right? So we have calculate here is 1,125 voltage. So you can calculate the factory. It is 11,000 minus 1,125 voltage. You can calculate the final answer. I guess it is like maybe it is for 9,875 voltage. Okay, this is for the power, the potential difference on the factory. And then you can use the formula that the power equals to U times I, that is 9,875 voltage times the current is 750 ampere. Okay, so maybe here you have to use the calculator to find the final result. Okay, so this is for today's our lesson. So see you next time. Bye.